The true explanation for your presence here has nothing to do with yourself. Constructing a single human being consumed 13.8 billion years of cosmic history. This wasn't because biology is complex, but because your physical form consists of atoms that were non-existent at the start of time. Every calcium atom in your skeleton, every iron atom in your veins, had to be created inside a dying star over billions of years before becoming part of you. By the end, you'll understand why neither God nor physics could have created you sooner. There were only two paths forward, each demanding a cost. Begin with the number most overlooked, 13.8 billion years. Say it slowly. That marks the universe's age. Humans in any recognizable form have only been around for about 300,000 of those years. Calculate the fraction, and you get roughly 0.002% of cosmic history. If the entire age of the universe were compressed into one calendar year, humans would arrive at 11:58 p.m. on December 31st. But that timing isn't random. And once you see it, you can't unsee it. Here's the escalation. Why so late? The simple answer is evolution. Life needed time to develop. That's accurate, but it's not the profound answer. The profound answer is elemental. Your body is roughly 65% oxygen, 18% carbon, 10% hydrogen with smaller amounts of nitrogen, calcium, phosphorus. None of it existed in the first few 100,000 years after the Big Bang. The early universe was almost entirely hydrogen and helium, just two elements. No carbon, no calcium, no iron. If God or physics had tried to build you on day one, there was nothing on the periodic table to build you from. Think about your last physical. The doctor draws blood, checks your iron levels, maybe your calcium. Ordinary numbers on a lab report. Nobody in that room thinks about where that iron came from. But here's the scene worth sitting inside. Every atom of iron in your blood was forged inside the core of a star at temperatures over 100 million degrees in the final seconds before that star collapsed and exploded as a supernova. Not the sun, a star that died likely billions of years before our solar system even existed. The explosion scattered those atoms across space like ash from a fire. And over unimaginable stretches of time, gravity gathered some of that ash into a cloud. And that cloud became the Earth. And some of that iron ended up circulating through your veins right now as you sit there. You are quite literally breathing and bleeding the leftover material of a star that no longer exists. That's not poetry. That's a measurable, verifiable fact about the periodic table. The iron in a hospital blood test and the iron forged in a collapsing star are the same atoms, just relocated by about 4.6 billion years. And that's where the real question hides. The one that changes everything about why you're here at all. The real question, the one that breaks everything, isn't why did God wait so long to make humans? That framing assumes waiting was optional. The real question is, could God or the laws of physics have made a human being any earlier than they did given what a human being is actually made of? Because if the answer is no, if the raw materials for you simply did not exist until stars had lived and died multiple times over, then the delay wasn't a delay at all. It was a prerequisite. And that reframes the entire creation story, religious or scientific, from a choice into a constraint. Here's where the assumption breaks. Go back to that early universe, hydrogen and helium. That's all there was. The universe didn't just need time to make you. It needed deaths. Specifically, it needed multiple generations of stars to live and explode before there was enough carbon, oxygen, nitrogen, calcium, and iron scattered through space to build a planet, let alone a person. Here's the mechanism with real numbers. The first generation of stars, astronomers call them population 3 stars, formed from pure hydrogen and helium, roughly 200 million years after the Big Bang. These stars were enormous, some over 100 times the mass of our sun, and they burned through their fuel in only a few million years, a blink, cosmically speaking. When they died, they exploded as supernova. And for the first time, elements heavier than helium were released into space. Carbon, oxygen, a little iron. But one generation wasn't enough. Those elements had to be swept up into a second generation of stars, which lived, fused heavier elements in their cores, and died again, producing more calcium, more phosphorus, more the heavier elements a body needs. Our own sun is estimated to be a third-generation star, meaning at least 2 full stellar life cycles, each spanning millions of billions of years, happened before the raw material for Earth, let alone a human, existed. At around 9.2 billion years after the Big Bang, our solar system finally formed with enough heavy elements finally present to build a rocky planet. That's the partial payoff. The wait wasn't neglect. It was manufacturing time. But here's what stays open. Why does it take specifically the death of a star to make these elements? What is actually happening inside a collapsing star that a normal living star cannot do? That mechanism is stranger than most people realize. And it's next. The textbook says stars are just balls of burning gas, hydrogen fusing into helium, releasing light and heat. The same reaction over and over until the fuel runs out. That's true, but it's incomplete. And the incompleteness is where the real story lives. Because what actually happens in the last minutes of a star's life is closer to alchemy than to fire. And it's the only thing in the universe that can build the elements you're made of. Here's what the textbook simplification misses. A star spends most of its life fusing hydrogen into helium. That's the burning everyone pictures. But as a massive star ages, it starts fusing helium into carbon, then carbon into oxygen, then progressively heavier elements. Each fusion stage releasing less energy and requiring higher temperatures than the last. This continues in layers like an onion until the star tries to fuse iron. And here's the part that surprises almost everyone. Fusing iron doesn't release energy, it consumes it. Iron is the point where fusion stops paying off. The moment a massive star's core turns to iron, the star loses the energy output that was holding it up against its own gravity. The core collapses, not slowly, but in about 1/4 of a second, and rebounds in a shock wave so violent it blows the outer layers of the star into space at tens of thousands of kiloohm per second. In that instant of collapse and explosion, temperatures spike past 1 billion degrees. And for a few brief seconds, the star fuses elements heavier than iron, gold, platinum, uranium through a process called rapid neutron capture. Elements that took millions of years to build up to iron get finished in seconds during the star's death throes. Which means the gold on your finger and the calcium in your teeth were both forged in less time than it takes to read this sentence, but only because the star was dying while it happened. So, the surface story, stars burn fuel, is technically true, but misses the actual mechanism. The elements that make up your body weren't built during a star's stable burning phase at all. Most of the heavy elements were built in the final seconds of catastrophic death. You're made quite specifically of stellar death, not stellar life. Picture this. It's 4.6 billion years ago. There is no Earth yet. Only a vast, slowly rotating cloud of gas and dust, roughly light years across, drifting in a spiral arm of a galaxy that doesn't have a name yet because there's no one to name it. This cloud is not pure hydrogen and helium anymore. Scattered through like flecks of ash through smoke are atoms of carbon, oxygen, iron, calcium, gold. Debris from stars that lived and died long before this cloud even began to collapse. Now watch it happen in real time. Gravity, patient and relentless, starts pulling the densest parts of the cloud inward. Over about 100,000 years, the center of the cloud heats up, compresses, and ignites. A new star is born, our sun. Around it, the leftover material, the same scattered stellar ash, begins clumping together, grain by grain, then pebble by pebble, then boulder by boulder over tens of millions of years, until you have a molten rocky sphere, Earth. Here's the moment you're inside the paradox. Every atom of iron now sitting in the core of that molten planet, every atom of calcium drifting in its crust, every atom of carbon suspended in its early poisonous atmosphere. None of it is new. All of it is secondhand, recycled. You are standing in this thought experiment on a planet built entirely from the wreckage of stars that died before your solar system existed. And somewhere in that wreckage, in atoms that don't yet know what they'll become, is the calcium of a skeleton, the iron of blood, the carbon of a brain that will one day ask why any of this happened. The resolution is only partial, and it's meant to be. You can feel standing in that imagined cloud of stellar debris that something is being assembled toward you, but you can't yet see the shape of it, and neither could the universe for a billion years before you existed. If every atom in your body already existed inside a star that died before Earth was born, are you really new? Or are you just the universe's material rearranged one more time? Because what happens next in that cloud of debris is the part almost nobody gets taught, and it changes what creation even means. You just stood inside that cloud of stellar debris, watching a planet assemble from recycled star matter. Now let's understand what that process actually means at 3 depths. Think of a universe as a kitchen that started with only 2 ingredients: flour and water. Nothing else. No sugar, no eggs, no salt. You cannot bake bread, let alone a cake, from flour and water alone. Stars are the ovens. Each generation of stars cooks a few new ingredients into existence. First sugar, then salt, then eggs. And when the oven breaks apart in an explosion, those new ingredients scatter across the kitchen counter for the next oven to use. It takes several broken ovens, several generations of star death before the kitchen finally has enough ingredients on the counter to bake something as complex as a human body. Picture the counter after the first oven breaks. A small pile of carbon, a trace of oxygen. Not nearly enough. It takes a second broken oven, then a third before there's flour for bone and yeast for blood. No shortcuts. No way to skip ovens because the ingredients for calcium and iron and carbon simply do not exist until a star manufactures them and then dies to release them. Now, here's the same idea, but in the language physicists actually use, and it reveals something the kitchen metaphor can't. Stellar nucleosynthesis, the process of building heavier elements inside stars, follows a rough hierarchy based on binding energy, which you can think of as how tightly packed a nucleus is. Fusion releases energy when you combine lighter nuclei into a more tightly bound nucleus up to iron, which has the tightest binding of any common element. Past iron, fusion costs more energy than it releases. That's why iron becomes a dead end that triggers stellar collapse. Elements heavier than iron require a different mechanism: rapid neutron capture, where free neutrons slam into a nucleus faster than it can decay, building up mass in seconds rather than over millions of years. This is a reading well supported by observation. The 2017 detection of a neutron star merger, confirmed through gravitational waves, and a follow-up light signal showed astronomers gold and platinum being forged in real time, matching decades of theoretical prediction. Before that detection, this was a strong hypothesis. Now it's measured fact. In human terms, your body needs both processes: the slow fusion inside living stars and the violent neutron capture dying ones working across multiple star generations to have every element on its ingredient list. Skip one generation, and the periodic table on your kitchen counter stays incomplete. And once you follow that logic to its fundamental layer, you land somewhere almost nobody expects. You are not a separate thing that was placed into the universe. You are a late-stage configuration of the same matter the universe started with. The same protons and neutrons formed the first few minutes after the Big Bang. Rearranged, cooked, exploded, scattered, and reassembled across roughly 9 billion years before your specific arrangement happened to include a working brain that could look up and wonder about it. Whether you frame that as God's process, a creator choosing to work through cosmic time rather than instant assembly, or as physics process, a universe with no author, simply following the only sequence of steps that could ever produce something like you, the sequence itself doesn't change. Some physicists describe this as an anthropic observation. We necessarily find ourselves in a universe old enough to build us, because a younger universe couldn't have. That's a reading many scientists find compelling, but it's an interpretation, not a proof. It describes a condition for our existence without settling why that condition holds. There's a strange comfort hiding in this if you sit with it long enough. It means the calcium in your skeleton and the oxygen in your lungs are not really yours in any permanent sense. They're on loan, mid-journey, borrowed from a star that finished its life so that yours could begin. What's not in dispute is the mechanism. No stars, no death, no you. Take that fundamental layer. You are recycled stellar material. And follow it across scale, smallest to largest. At the atomic scale, a single carbon atom in your bloodstream right now has existed in some form since a star fused at roughly 5 to 10 billion years ago. It has been part of interstellar dust, part of the early solar nebula, part of rock, part of ocean, part of plant, part of animal, and now part of you. And when you die, it will continue on, unbothered by the arrangement it was just in. At the molecular scale, zoom out slightly, and those atoms are already assembled into something stranger. The DNA coiled inside nearly every one of your cells. The phosphorus in that DNA backbone was forged in a star. The nitrogen in its bases was forged in a star. Even the specific arrangement, the double helix itself, only became chemically possible once enough carbon, nitrogen, and phosphorus existed in one place at once. Stellar death didn't just supply your ingredients. It supplied the ingredients for the instructions that built you. At the human scale, an adult body contains roughly 7 octillion atoms. A 7 followed by 27 zeros. Nearly all of the heavy ones, calcium, iron, phosphorus, zinc, trace back to stellar death. You are by atom count mostly hydrogen from the Big Bang and oxygen from stars. The rarer heavy elements, gold and iodine among them, in trace amounts in your body, may have required not just ordinary supernovae, but the far rarer, more violent neutron star collisions to be forged at all. At the planetary scale, Earth itself is a leftover, a byproduct of the same stellar debris cloud that built the sun. Every mountain, every ocean, every vein of iron or ever mined is recycled star material that happened to cool into a sphere instead of igniting into a second star. The only difference between the sun and the Earth chemically is which pieces of stellar debris ended up massive enough to ignite fusion, and which didn't. At the galactic scale, our entire galaxy contains roughly 100 billion stars. And astronomers estimate several generations of star birth and death have cycled through it since it formed. Each cycle enriched the next generation of stars and planets with slightly more heavy material than the last, which means galaxies that formed later in cosmic history, or regions still actively forming stars, may be building planets with even richer chemistry than the one you're standing on. At the cosmic scale, the same process, stars living, dying, scattering elements, seeding the next generation, is still happening right now in nurseries of star formation across the galaxy, like the Orion Nebula, roughly 1,300 light-years away. Somewhere in that nebula, elements are being forged tonight that might 9 billion years from now become part of something that asks the same question you're asking right now. Pull that cosmic implication back down to human scale in one movement. Right now in the Orion Nebula, atoms are being forged that could 9 billion years from now become part of mind capable of wondering where it came from. That is exactly what happened to you just 9 billion years earlier in cosmic history. Here's a slow reveal in 3 steps. First, you assumed at the start of this video that God or chance could have made a human at any point after the Big Bang and simply chose to wait. Second, the physics shows that assumption was backwards. A human being made of carbon and calcium and iron was not possible until multiple generations of stars had lived and violently died to manufacture those elements, a process that took roughly 9 billion years, no matter who or what was running the universe. Third, and this is the part that closes the loop from the very beginning of this video, you are not late. You are not a delayed arrival to a party that could have started sooner. You are the earliest possible moment of being made of your ingredients could exist. The wait wasn't God's hesitation, and it wasn't cosmic accident either. It was a minimum construction time for you specifically, an absolute floor set by the physics of how heavy elements are made, not a ceiling anyone chose to enforce. So which is it? A universe with no author in which this timeline was simply the only physical sequence that could ever produce something able to ask why? Or a creator who worked through 9 billion years of dying stars because that was the only way to build you out of the only materials available. Physics can tell you the mechanism. It cannot tell you whether there's an intention behind it. That question stays open, honestly, deliberately open because nothing in the periodic table settles it either way. Maybe that's the wrong place to look for an answer anyway. Maybe the answer isn't hiding in a lab or in a scripture, but in the simple fact that the question can be asked at all. That after 9 billion years of stars living and dying in silence, something finally arrived that could look up and notice. Whether that arrival was intended or inevitable might matter less than the fact that it happened and that you're the one it happened to. Here's the concrete image to leave you with tonight. If you can look up at the sky Every point of light you can see is either a star still cooking elements inside itself, or the location where one already finished and scattered its ingredients into the dark, some of which, billions of years later, ended up as you reading this sentence, made of the wreckage of something that burned out long before you were ever possible. You were never late. You were the earliest you could ever be. If that question about intention is still sitting with you, the next one goes further. If God built the universe through 9 billion years of dying stars, who built the rules those stars had to follow? It's on your screen.